Picture this. You're walking into your Cambridge IGCSE Computer Science 0478 exam. Your programming logic is absolutely flawless, yet you're about to lose up to 20% of your marks. Crazy, right? Well, it's happening because you're falling into a massive trap that almost every top student steps right into. So what exactly is the most devastating mistake top students make on paper 2? Here is the brutal confession. Brilliant programmers, we're talking students who literally know their algorithms inside out, are just throwing away easy marks. They go in and write these beautiful textbook definitions, but they completely ignore the scenario-specific nouns and constraints. And honestly, that's fatal. See, giving generic answers equals a massive grade boundary risk. Your ordinary revision completely fails you here because Cambridge examiners actively penalize those generic responses. Like, it really doesn't matter if you can recite the perfect dictionary definition of an array or a loop. If you don't apply those computational concepts specifically to the problem right in front of you, using the examiner's exact terminology, you drop marks. It's that simple. And it is the absolute fastest way to slip down a grade boundary.
All right, let's move into Section 1, Choosing Your Arsenal, focusing on the 3 languages. To build up our technical foundation and dodge this trap entirely, you should know the Cambridge syllabus officially recommends 3 core options. We've got Python, Microsoft Visual Basic, and Java. Now, while the syntax, the actual words and grammar you're typing out, varies across these 3, the underlying logic is perfectly identical. For this explainer today, we're going to use Visual Basic as our core example. Why? Because it just perfectly bridges that gap between learning the foundational logic and actually building commercial-style programs.
But hold on a second. Before we get into the coding itself, I really need to pose a critical question to you. What is the hidden examiner clue that changes your answer entirely? Stick with me, because in just a moment, I'm going to reveal this secret examiner clue that literally secures full marks. But first, we absolutely have to build the technical foundation that makes that clue super obvious. Which brings us to Section 2, the Visual Studio 2019 Community IDE. An integrated development environment, or IDE, is where your code actually comes to life. It's a huge upgrade from just scribbling pseudocode on a piece of paper. It's the primary tool that programmers use to write, compile, debug, and test their code all in one single place. Within it, we're looking at 2 main application modes. On one side, you have the console application. This is a textual command line interface, totally uncluttered by any graphics. It's perfect when you're first learning core algorithms. Then, on the other side, we have the Windows Forms application, which gives you a much richer, commercial-style graphical user interface, or GUI. The source material emphasizes that jumping between both formats drastically improves and supports the development of your computational thinking. Now, whether you're using a console or a Windows form, your code relies entirely on this precise Cambridge definition, a construct. Cambridge defines this exactly as a method of controlling the order in which the statements in an algorithm are executed. The source text gives this fantastic analogy that I just love. Think of a professional badminton player. They really only have a few types of shots, right? Drop shots, clears, maybe hard-driven smashes. The true skill is combining those specific shots to execute a winning strategy. Well, programming is exactly the same. We are basically just combining a limited range of simple constructs to build satisfactory solutions to really complex tasks. Okay, let's look at Section 3, the High Mark Exam Strategy Framework. Let's actually turn that raw programming knowledge into hard marks. Cambridge deliberately uses very specific command words, things like state, define, describe, explain, calculate, show, evaluate. The absolutely crucial point here is that you must have strict command word awareness. Typically, 1 mark demands 1 distinct technical point. Do not, and I can't stress this enough, do not repeat the same exact idea twice in an explain question just using different words. If you do, you're just wasting your precious exam time and throwing away points. So, how do we conquer those command words? You've got to rhythmically drill this 4-step response formula right into your revision. Step 1, state the concept. Step 2, provide the evidence or data straight from the question. Step 3, apply the scientific reasoning. And finally, Step 4, finish it off with precise examiner wording. This structured approach is a game changer. It takes an average, rambling answer and upgrades it into an elite, highly focused one every single time. Let's actually see this framework in action. A flawed student answer might say something like, the program checks if data is right. Look, that gets you 0 marks. It's way too vague and non-technical. Contrast that with this top band upgrade. Validation checks reasonableness. Verification checks entered data is correct using scenario constraints. You see the difference there? We define the exact mechanism, we clearly separated validation from verification, and we use the exact, precise phrasing that those examiners are actively scanning for.
And wow, that brings us perfectly back to that hidden examiner clue I promised you a minute ago: scenario nouns and constraints. Guys, the absolute secret to full marks in paper 2 is forcefully injecting the scenario nouns directly from the question right into your technical answer. If the exam question is talking about a temperature sensor in a greenhouse, do not just write "the sensor checks the data." No way. Write "the temperature sensor checks the greenhouse heat data against the boundary constraints." Being generic is weak, but tying the concept right back to the scenario nouns, that is elite.
All right, let's test this framework out right now. I want you to actively engage with this. I want you to pause and predict. How do you explicitly distinguish normal, abnormal, boundary, and extreme test data when evaluating an algorithm? Take a quick second, think about how you'd write this out to get full marks, making sure to keep those specific scenario constraints in mind. Okay, time's up. Let's look at the examiner's style feedback. If you predicted something weak, like just test different numbers, I hate to break it to you, but you're losing marks. The elite response specifically states, test normal expected data, boundary data at the exact limits, and extreme data outside limits. And to make it a truly top-band flawless answer, you would tie those exact limits to the specific nouns in your scenario. Whether they're talking about greenhouse temperatures or a user's password length, you have to name it. Real quick, before we hit the final trap of this explainer, I just want to remind you, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We are constantly breaking down these essential strategies to make sure you get the absolute best grades possible, so hit that subscribe button. Okay, moving on to section 4, the next step, which covers common traps by question type. So you've got the core strategy down. You understand constructs, the IDE, and that killer 4-step framework. But listen closely, because your correction sequence isn't quite over yet. Knowing the strategy is really only half the battle. Knowing where examiners deliberately set traps based on the question type, well, that's the other half. So I'm going to leave you with this provocative thought. The strategy is set, but can you spot the fatal errors hidden in specific question types? Watching our next explainer on common traps by question type is absolutely mandatory to complete your exam armor and guarantee those top marks. You really cannot afford to walk into that exam room without knowing what they're trying to trick you with. So I will see you in that next explainer.